Okay, welcome. Today we are going to look at transformations of quadratic functions and transformations in general. What we need to look at is we're going to look at first the quadratic parent function, and then we're going to understand how by applying different coefficients and constants to the function, we can transform it up and down, stretching it and compressing it, reflecting it. So firstly, we're going to look at the effect of this number here. We're going to see what happens. We're going to see what happens when we multiply by a number like this. We're going to see what happens when we add a number. We're going to see what happens when we add a number inside the bracket like this, and look at the different effects. So first up, to do that, what we need to do is we need to go to GeoGebra. So make sure you go to geogebra.org/classic. A lot of you end up in the calculator one, and it's not going to have the buttons in the same place as mine. First up, we're going to add the quadratic parent function. So your basic quadratic function is a function that looks like this: y equals x squared. What's interesting about this function is there's a couple of key points. It has this key point here, a, which is like this, which is at 0, 0. Has another key point here at b, which is at 1, 1. This is the quadratic parent function. This is how it looks. So it goes through the origin at 0, 0. And it goes through 1, 1, and then it goes for each integer value, 2, 3, 4. It goes through 2, the square of 2. So 2, 4, 3, 9, 4, 16, 5, 25, because it's created by x squared. It squares whatever the number is. This is the quadratic parent function. And we're going to look to see how we transform that. So we're going to need 3 parameters to use. So we'll pull up a slider like this. We'll click here. Our first slider is going to be called A, and I'd like to give it an increment of 0.25 for this one. So we'll give it a 0.25 increment. We're going to create 3 sliders. We'll create them all straight away. Our next slider is going to be called K. So our next slider is going to be called K, and we'll give this one an integer increment of 1. Our last slider, just click here. Our last slider is going to be called H. This is also going to have an increment of 1. Okay, so first up, what we're going to do is select the pointer tool again so we can move things around. And we're going to reduce these two down to 0. So there's H, there's K. We'll have these set at 0. And A up here we'll have set at 1. All right, so we are going to look at the effect of the value A. So we're going to create a quadratic function that looks like this. Go into here. Sorry, I'm a little bit short. Let me move that one out of the way. Yeah, that'll do. Hopefully you can see me. I'm typing y equals a times x, and I get the squared button by pressing the hat, which is on shift 6, and then squared, and then enter. So here we have 1 times a squared. We don't see this function, so that we can see the function, I'm just going to change the color of it. So here in the settings, again, I'm just going to make this one blue. We can see it now. So we can't see the original function because they're exactly the same function. At the moment, they're both y equals x squared. If I take my slider for a and I make a bigger, on this one, I'm going to, if you notice the effect of the function, it's getting narrower. It's getting narrower and narrower, like this. So as we make a bigger and bigger, it goes more and more narrow, like this. We bring a back down to 1. here at this point, and it lies back again on top of the original function. And then as I make this a little bit smaller, here at 0.5, notice it goes wider. It goes wider. So we need some vocabulary to describe what's happening here. I'm going to add in another point. Notice that both the functions, no matter what my value of a, it's still going through 0, 0 at this point. So this coefficient here is create what we call a stretch or a compression. I'm going to add another point in. So we had 1, 1. So this time I'm going to go 1, comma. Now my second function is called g, so I'm going to do g of 1. This will plot the point on our new function when x is equal to 1. So as I change my value of a, watch how that point goes up. Let me just go find the point and add the value. Settings, add the value. Okay, so look at this point here now. Look at the value of a. Look at the value of a here. Look at the y value there. Look at the values. Watch how that changes as we change a. Ooh. Okay, so as I make a 1, it starts at 1. I make a 2, it's at 2. I make a 4, it's at 4. Let's go down a little bit and make a 0.75 or 0.5. It's at 0.5. So this coefficient is what we call the vertical stretch, vertical compress, depending on whether we're going up or down. So A equals vertical stretch or compress. This is what the value of A is. Okay. So now we will go back to putting A equal to 1. And now we will have a look at A again. What was A when it was negative? We didn't go negative. We went vertical press, vertical stretch. Let's go down and make A negative 1. Look at that key point. It's 1, minus 1. Now that A is negative 1, it's adding a reflection. So if you have a negative sign in front of A, it's going to create a reflection. Instead of the function having a minimum point, the function is going to have a maximum point. So we come up to a maximum now because we have a reflection in the x-axis created by A. But we still have the same stretch and compress. So for instance, if I go to minus 2, it's going to go to that key point, it's going to go to minus 2 as well. So we have a reflection and we have a stretch. So it's best to think of it as stretching it up to 2 and then reflecting it down to minus 2. It's going to create stretch and a reflection. So this is another of the effects of the coefficient A. It's going to create a reflection. Okay, I've got A set at 1. We're going to look at the effect of K. We're going to have a look at the effect of K. So this time, I'm going to go back to this function here. I've got my A, x squared. I'm going to put plus K and add in another constant. So the function I'm working with now, currently, is y equals ax squared plus k. This is the current function. So k is at 0. The function looks exactly the same as the quadratic parent function. I make k equal to 1. What's changed now? Look at the two key points. 0, 0 has moved up. Let me plot that point. I haven't got it all plotted for you. So we want 0, g of 0. So to plot that point, I'll just add the value. So that point now, which was at 0, 0, has gone up to 0, 1. The point that was at 1, 1 has gone up to 1, 2. Let's increase k again. Increase k to 3, and they've both gone up again. So 0, 0 has gone up to 3, 0, 3. 1, 1 has gone up to 1, 4. So what we see as the effect of k is it's going to create a vertical shift or a vertical translation. So if k is positive, the whole function moves up by the value of k. Let's see what happens when k is negative. If k is negative, the whole function moves down by the value of k. So the vertical shift or vertical translation is k by k units. So in this case, we've gone, k is minus 3, so we have had a vertical shift 3 units down. K is equal to plus 3, we have had a vertical shift 3 units up. K is equal to 5, we get a vertical shift 5 units up. K is equal to minus 2, we get a vertical shift 2 units down. Let's see what happens when we mix the two. If we put in a equal to 2 as well. Now what's happened? Notice, to see the shift, look to the vertex. Because at that key point, it looks like that point has gone down by only 1, whereas the vertex has gone down by 2. Look, to see the k value, you see it only at the vertex. So this has gone down by minus 2, and then the function has been stretched up. So let's have a look. By going down by minus 2, we should be coming through here at 1, minus 1, because it's coming down by 2. But after it's become down by 2, it's been stretched up, also doubling the value. So the best way to look at these two is that the function will get stretched up first to 2, and it will be at 2, 2. Stretch comes first, and then we get our vertical shift down. So 1, 1 goes to 2, 2, and then we get our vertical shift down 2 units. So that's why it's coming in here. Let me clear the board a little bit. Okay, we're going to explore this a little more. Right, so k is our vertical shift, and a is our vertical stretch and compress. Both of these two are on the outside of the function before the function happens. Oh, sorry, after the function happens. After the function happens. Both k, so let me just draw that with my pen, see what we're talking about. I feel like a new color time. When we have y equals, oh, look at this shade of pink, isn't it good? The function is happening here. The function is happening here. We get an x and then we square it. Both of the vertical movements happen after the function has been found. So we find the value of the function x squared, then we multiply it by something, giving us our vertical stretch or our vertical reflection, and then we add k last, giving us our vertical translation. So k equals vertical shift or vertical translation. Using both terminologies there, vertical shift is shortest, I'll write that. Vertical shift. Now, in our next one, we are going to look at the effect of h. Now, h happens before the function. So we've got ax minus h. So we're going to have a negative sign plus k. So we're going to have ax minus h squared plus k. So the h is happening inside the function. It happens first. Everything that happens inside the function happens backwards, kind of. So what we're going to do is we're going to have a minus sign to compensate for it happening backwards. We're going to have a minus sign. So where's our function? Our function is here now. We've got ax squared plus a. We need to add a little bracket in here. So let's add a bracket there. Let's get my glasses on. Let's close the bracket there. So we got a bracket in the right place, and we want to subtract h like this. So at the moment h is 0, so nothing's happening. At the moment h is 0, so nothing's happening. Let's see what happens when I make h1. So I make h1, and if you notice, both of the points move one to the right. I make h something big, 4. All of the points are moving to the right. I make h negative, and the points are coming backwards this time. The points are coming backwards this time. So this one is creating a horizontal shift. Now the key thing to see is which one is moving and which one is not, so to speak. So let me just change the key points. I don't want to use 1. I want to use 1 plus, because it's happening inside the function, I need to do 1 plus h on these ones. So 1 plus h there for that one. And on this one, 1 plus h. And then for our vertex, we don't want it at 0. We want it at 0 plus h, because h is happening inside the function. So we have to change the value as well here like this. Now, we see our 2 points. Notice how they're going 4 to the left. Both of them go 4 to the left. If I add in one of the other features, like the stretch, here like that, add in one of the features like the stretch, we see it stretches up and then it moves 4 to the left. Sorry, it moves 4 to the left and then it stretches up. So this one's happening first. So the horizontal translation happens first, and it's all down to the order of precedence of operations. If you were to put in values into this function, if you were to put values in and evaluate it, you're going to do x minus h first. Then you're going to square it. Then you're going to multiply by a. Then you're going to add k. And this creates our different translations. We call this one, I think it's time for some green. We call this one horizontal shift. Now, one last key feature to notice is the coordinates of this vertex here. What are the coordinates of this vertex here? It's minus 4, 0. What are the values of h and k? Minus 4, 0. Look at the values of h and k. Look at the values of the vertex. Let's make h and k some different values. Let's make, we'll leave a at 2. Notice a has no effect on the vertex. No effect on the vertex. Let's put this at 1. Take that effect away. Let's make k something higher, 2. Let's make h positive, 4. Look at the coordinates of the vertex. Look at the coordinates of the vertex. The vertex is at 4, 2. H is 4, k is 2. Now the important thing to look at when you see the function, where is my function? My function is here. Now, when you look at this function and you're getting used to it, a lot of people get confused by the fact it says x minus 4. X minus 4 means h is 4, because the general form of the function is x minus h. So when you're trying to figure out the coordinates of the vertex, if a vertex is at 4, 2, we need x minus 4, bracket squared, plus 2. All right, let's leave that investigation a little bit. So have a go now for yourself at describing the effects of the different parameters a, h, and k. I'm going to pause the video. Okay, welcome back. Sketch each function. So I'm going to move a little bit quickly with this one so I can get finished before class starts this morning. So we need to sketch the functions and practice sketching the functions. We have got one coefficient here. So start off by drawing your quadratic parent function, y equals x squared. for comparison. We need this for comparison. So now we can draw y equals x squared plus 3. What's going to happen here is there's going to be no change to the shape of the function, and it's going to move up by 3 units, vertical shift. So the vertex is going to be at 0, 3. Our key point at 1 is going to be at 1, 4. This is how the function will look. Vertical shift. This is a vertical shift, 3 units. Let's look at the next one. So here we have an h. What is the value of h here? So in this one, we have k is equal to 3, we have a is equal to 1, and we have h is equal to 0. Here on this one, a is equal to 1, h is equal to 4, not negative 4, and k is equal to 0. So we're going to have no stretch or compress, we're going to have no vertical shift, but we are going to have a horizontal shift. So we draw a quadratic parent function for reference, y equals x squared, and then we draw our new shifted function. Now, h is 4, so it's going to move 4 units to the right. It's going to go through, have its vertex at 4, 0. Okay, we need to have a look at this one. So we've got a is equal to 1. There's no vertical compress or reflection. H is equal to -2, because this should be x minus 2. K is equal to -4. So the vertex is going to be at -2, -4. We can see that here in the function. So we draw our graph like this. We draw our axes. We put in our we draw this a bit better back there. Yeah. We draw a quadratic parent function. This is y is equal to x squared. So then we need to find the new vertex. It's going to be at -2, -4. So start there, -2, -4. And then draw a parabola that is the same shape as the one given, as best you can. Here we have a horizontal shift left by 2 units and a vertical shift down by 4 units. Last one now. Start by drawing our quadratic parent function. Oops, need it a bit better than that. There we go. This is y is equal to x squared. What are the values of a, h, and k? A is equal to 1/2. H is equal to 0. K is equal to 3. So what is the new vertex? The new vertex is going to be at 0, 3. So we plot that point there, 0, 3. Now we draw our function, but this time the function has been compressed like this. So the function is going to have this type of a shape. So I'll sketch it like that, put it here, erase that one. That was just my guide, so I get the shape about right. So notice it's wider and more open because of the effect of the vertical compress. Vertical compress, factor 2. There's a vertical compress of factor 2. Okay, what are the values of h and k? A is equal to -1. H is equal to -2. K is equal to 3. The new vertex will be at -2, 3. We draw up our axes. We draw our quadratic parent function. New vertex, -2, 3. So -2, 3 is going to be here. -2, 3, something like that. This time, we have a vertical reflection. Vertical reflection. So our new function has the same shape as the quadratic parent function, but it's reflected, so it's going down. Let me draw some axes up for this one. What are our values of h? of A, H, and K. A is equal to 2. This means a vertical stretch 2 units. H is equal to -1. Horizontal shift left. K, 1 unit. K is equal to 5. Vertical shift up 5 units. We have the new vertex is at -1, 5. We draw the quadratic parent function, y equals x squared. Then we plot our new vertex. Our new vertex is at -1, 5. It's going to be up here somewhere, -1, 5. And then we have to show a function which is narrower than the original function. It has to be narrower. This one has a vertical stretch factor 2. Okay, so in brief, that summarizes the effect of the transformations on the quadratic parent function. I'm going to stop the video here and start up a new one for the next bit.